Hello. All right. A very good morning to every one of you, and thank you for joining us today for our little panel discussion today. And our topic is um, air to liquid, training your team to transition to liquid cooling. And I have with me Mark Bulmer, who is from GF Piping Systems, as well as Zakharia, who is from Eaton. All right. So let's give that a big hand again, shall we? Thank you very much. Right. And you know that liquid cooling has been a hot topic literally because of the demand for greater density data centers. Liquid cooling isn't new. It's been around for quite a long time, but again, it has never received so much attention and so such rapid deployments. So we want to hear from the experts themselves, right? What is seeing out in the field? And my first question really is, liquid cooling is all good and fun, right? But what are the biggest knowledge gaps you see when it comes to the operational teams uh, when they first move from air cooled to liquid cooling? I don't know. Should we have Mark to go first?
Hello, everyone. Nice to be here. Thank you to be on the stage with Paul. It's my pleasure. My name is Mark Bulmer from the company George Fisher Piping Systems. So I'm based in Switzerland. We are a global company. And to answer the question with regard to the move from air to liquid and the challenges that we face, we have been in the data center industry, in the data center vertical. We have had many hydronic applications in our facilities for many years. And also, as you mentioned, Paul, they're also including DLC, but not on scale. This is also one of the key factors. Also, the hydronic applications we've had, chilled water and condenser water, have been in non-critical areas. Obviously, they're mission-critical cooling because it's water to air, but they have not been so close to the computer. Even rear door heat exchanger, below floor, etc., has been removed, let's say, from the geographically, environmentally, from the actual chips. Now we are moving to actually having the liquids or fluid direct contact with the actual functioning chips. And this puts completely different demands on the functionality of the piping system and also the reliability of the piping system. It also is an aspect with regard to the development of the chips next years. We've seen how Blackwell chips from NVIDIA have increased in cooling capacity the last few years, and it will carry on. This development in terms of chip power performance will not stop. So when we are designing these hydronic piping systems now, they have to be future-proofed for the next 3-4 years. So they have to be designed almost over-dimensioned to cope with the potential developments of chips over the coming years. This is not so easy. One has to think about it. You're designing something, and we don't know exactly what's going to arrive in the future. Yeah. Oh, the feedback. Sorry. So this is actually one of the major challenges at the moment: is future-proofing our hydronic design to cope with future developments over the coming years.
Is my okay? I just want to add, before you take over, and just now we had a quick discussion at the back just now, and we were just talking about in the past when you build a piping, you look at the data center specifications, you look at the fan walls or whatever system they're using, and you say, okay, let's build a pipe for that, and that's it. It's good for 5, 10, 15 years, right? But today you don't know what you're going to put in the server racks, right? Today it could be 50 kilowatts, okay. Tomorrow you could be bringing that some brand new Blackwell 130 kilowatts, and you're like, okay, maybe I need to redo the piping. So you need to future proof. But I'm intrigued. You mentioned about reliability. I mean, do pipings even burst? I mean, is it even a concern?
No, but there is a worry that they could. And also there is a danger, obviously, if they do, then the damage that can be caused within the rack. The focus for the client and his worries that the client has are basically around the rack. I think for the TCS and for the SFN systems, I say technical cooling systems, so the distribution piping from the CDU unit between the racks, actually there's no danger. Nevertheless, one has to be have the client in mind and his worries, just the worries. So leak detection is also highly important. Drip trays underneath the piping. These kind of design actions to be taken are to alleviate worry of the client, I think. But in real life, we supply also piping systems transporting highly dangerous acids into etching stations, in fabs, in the semiconductor industry, in offshore, really other critical environments, and nothing happens.
So basically, your pipes are good.
Yes.
Thank you. Let's move on.
Okay, so thank you so much for having us. So my name is Zach, everyone. I'm from Eaton. I from the field application engineer. So actually, I to design and to from the pre-sales area. So I talk about the technical. So currently, actually, Eaton has the end-to-end solution for data center, coming from the power, from the upstream, from MV until to the data hall rack. We have the LV MV solution and the UPS solution. Now we have also the cooling system. So I agree with you. Maybe some years, maybe 5, 10 years ago, we talk about the cooling system, talk about the crack, talk about fan wall unit, right? So now, when we talk about now and future, so we talk density rack is increased a lot because of the famous AI. You know, previously we talk about 5 kilowatt, 10 kilowatt, 12 kilowatt. Now easily we can talk 50, 60, 100, even more. So now we come up with the liquid cooling solution with the very suitable with the efficiency, the highest efficiency, and also the space. Because when talk data center, we also talk the space also. When we use the traditional one, right, with the high density, talk about maybe 100, 120 density rack. With the traditional, maybe the cooling system space is very big one. So with the liquid cooling, well, we are focused in the CDU unit, the direct to chip unit. So the space is very compact, and the efficiency very high. So it's the our concern to liquid cooling system in the data center solution.
Right. But what do you see as knowledge gaps that exist, right? I mean, it's easy to call you out and install them, but in the
Yeah.
field, what are some missing knowledge that you see?
What I see is, I think is the know of the system itself. I think the gap is the system. But I think when we talked 3 years ago, the gap is there. The gap is increased, the big gap. But I think we talk about 1 or 2 years later, so I think the gap is decreased because it's people starting talk about the liquid cooling. So people all trying to know how liquid cooling, how they works. So I think the knowledge is become decreased. So also the operation guy trying to know the how they work, the liquid cooling works, how the efficiency, how the performance. I think that's the gap. The system know from for the liquid cooling itself.
Right. I mean, it seems to me like it is the gap has always existed. It's just that I guess now everybody is banging on the table and saying, "Can I do it today?" Right? And the no people who know it, they are there, but they are not that many.
Yeah,
Right. So it becomes a problem. Mark.
Yeah, in terms of knowledge gaps, what we see is that if you're doing the hydronic system, I agree with Zakharia, basically that you have to think of it as a system. And people are not necessarily, everyone's looking still pleasantly at the moment in components, so the manifold rack, the UQD, the CDU. And we have to look at more, as we do with air cooling, actually, with CFD, look at more actual flow demands of the whole system. Keep the pressure drop only in the filter and in the cold plate. Design the system that there's virtually no pressure drop in the rest of the piping. This would be the end goal. This will be also then completely different speeds to that which you're using for air conditioning. Let's say the normal hydronic systems, chilled water. So we use a lot lower speeds to allow also future proofing. So down the road, that piping system can cope with higher demand by increasing the speed of the flow of the coolant slightly. So design the initial piping system at a low speed. I'm talking like 1 meters per second. So 0.8 to 1.2 meters per second. And then, whereas normally for chilled water systems, you're talking 1.5 to 2.5 meters per second. So a lot slower than you'd be normally. That gives you a larger piping system cooling capacity that can cope over the next years with future demands and also gives a certain reliability in terms of flow through the manifolds in the rack. So there are slightly different aspects to DLC compared to other hydronic systems in the facility. But as Zakharia says, I think, and you said yourself, Paul, that the design of DLCs has been around since the 70s, but now we are talking scale. Now we are not talking HPC, 10 racks, 6 racks. We are talking 220 racks, 660 racks. This is different.
Thank you very much. Now, from a piping perspective, I just want to know, right? What are some hands-on skills that technicians should master first? I don't know, chicken and the egg, right? Should it be the installation, leak testing, others, or design, or what? What comes first?
Basically, in terms of piping system, we have a very integrated, hands-on training system from George Fisher. This is very important to differentiate ourselves from building technology and utility piping. I mean, piping's everywhere, yeah. But we have to be aware of the environment that we're talking a mission-critical facility. So we offer certification of the trainers. This is highly important and very, very, very important for DLC, off-site manufacturing. I think also in power distribution and other areas from Eaton, it's also the case, is that off-site manufacturing is the future because the quality of workmanship can be held at a far higher level. You can have quality control. You can have pre-tested, pressure testing of spools. You can create spools for the hydronic system in a clean environment, which improves commissioning. When you come to commissioning, also a very big topic. So all these aspects are actually covered if you follow OSM, so off-site manufacturing is highly important for the skill and the workmanship in that area is to be high focused.
So sign up for your training. Zach, what do you say?
Okay, we talk about piping, right? In the cooling system, piping is the one of the important equipment because piping is to distribute the coolant, right? It's so very important. But I agree with because the piping itself, right? We need to know the QZ when the production. Even during the FAT, we can do the testing like the pressure test, and then we can join the welding, the join, and we can check during the testing. So the important thing is the QC during the production. Yeah, it's really important.
So interesting. So testing is important, but what I'm hearing from both of you is that QC is even more important, right? So if the product comes contaminated with, I don't know, metal shavings, contaminants, it will install well, it might even work for a while, but you might be in a world of headaches and pain later on because I don't know how you're going to clean up and flush out the pipes that's already working, right?
Yeah.
I don't think people do two-end pipings, do they? Not really.
Not really.
So better do it well the first time and do it properly, right? So I guess we are almost out of time. Maybe if you could just one last thought, about liquid cooling. If you were someone to come to you and say, tell me something about liquid cooling that I don't really know. You got 30 seconds. What will you tell them?
I would tell them to think of the complete system, to look at the complete design, as you do with air cooling when you're looking at CFD and doing that analysis of the air cooling over the racks. Think the same way for liquid cooling. Think of the flow through the manifold to the whole system. Avoid pressure drop in the piping. Put the pressure drop into the filter in the CDU and the cold plate. Over-design the rest of the system to allow for future capacities and to have virtually no pressure drop. And then you'll be future-proofed and you'll have an incredibly and off-site manufacturing involved that.
Yeah. Talk about liquid cooling itself. Maybe people worry because they don't know the system. Doesn't have a lot of proof in the system, right? But actually, the cooling itself is it's really suitable right now because of the high density, all the thing. Because right now, the cooling system, the liquid cooling system can give you efficiency more than the air cooling can give to you. So it's really talk about the performance and the efficiency. It's really important. We talk data center efficiency is important, right? Because the cooling system is one of the big power consumption. Also, so need the very good efficiency for the equipment.
So you're not thinking of liquid cooling, you should think of it today.
Correct.
That's what you're saying, right?
Definitely.
So thank you so much it's a pleasure having you, Mark and Zach. And if you need to have more chit chat with them, I think they'll still be around. Grab them and talk to them. Let's give them a big hand, shall we? Thank you very much.